Welcome back, guys. In this video lecture, we'll be discussing the various mapping techniques of 8085 microprocessor and how we can communicate with the I/O devices for 8085 microprocessor. So, in this here, we're going to learn two new instructions. One is the in instruction, and the other one is the out instructions. So these are the two main instructions which are used for communicating with the I/O devices. So if you want to input data from any device, then you can use the instruction in with 8-bit address. So 8-bit address. Let's say you have connected some device at uh, let's say the address 40H. So you can give the instruction as IN40 to input the data from the device, from the input device. Let's say you want to send some data into an output device which is connected at, let's say, 45. So the address 45. So you can just give the instruction out 45, and what happens is that the data that you want to out can be directly outputted to the address location 45, which contains an output device. So here we use 8-bit addresses for in and out instructions, and here whenever you give an in instruction or an out instruction, the device communicates with your A register, which is your accumulator. So let's say you're taking a 8-bit data from a device which is connected at 40. So what happens? The data goes directly into your accumulator, and from there, whatever you want to calculate, you can do from. Let's say there is a IO device, input device that is connected at address location 40, and you take a 8-bit data from this address from this device, and the data directly goes into accumulator, and whatever you want to do, you can do after that. And similarly, if you want to send the data into output device, the same happens over here using this out instruction. So let's say you have an output device connected at the address 45. So what happens? The data that is there in A register will be sent to the output device which is connected at 45. So these are 8-bit addresses. So uh, you can connect up to how many devices? Definitely, 2 to the power 8 is 256. So there are two types of addressings, and there are two types of mapping techniques. So we'll be looking at the two types of mapping techniques, and in one of them you can connect up to 256 devices. So let's see what is the two types of mapping techniques for I/O devices. I hope the in and out instructions are clear. So we'll further look into what are these instructions and what are these mapping techniques. So there are two types of mapping techniques. One is known as the I/O mapped I/O, and the other one is known as your memory mapped I/O. These are the two types of mapping techniques. These are the ways in which you can connect your I/O devices to your 8085 microprocessor. Either you can use a I/O address. It You can use a I/O address. As mentioned earlier, these are 8-bit address, or you can use a memory address. So memory addresses are, as you know, these are 16-bit addresses. So what happens is that instead of a memory location, you directly assign IO device at that location. So there are various advantages and disadvantages of using a memory mapped IO as well as a IO mapped IO. So here there are 8-bit addresses dedicated only for the IO devices. So here you can directly connect any IO device at certain addresses, and then you can keep accessing these IO devices using this IO mapped IO. So this is called IO input output mapped IO, which means that you are connecting your input output devices to the addresses allotted for the IO. It's very similar to your ports that you have on your system on your PC. So you have on the backside of the PC you have various ports, right? So each of these ports are like IO addresses, and you can connect various devices onto these ports. So and you can keep communicating with these devices. So that is what is known as a IO mapped IO. So in 8085 we use a 8-bit address, and therefore in IO mapped IO you can connect up to a maximum of 256 IO devices. But the advantage of memory mapped IO is that here you will give a 16-bit address. So definitely you can connect up to 2 to the power 16, which is 65536. So definitely you are increasing the range from 6500 and 536. So that is the main advantage over here, that you can connect more number of devices, IO devices, in memory mapped IO. So basically you are allocating the same address that you have for memory location for input output device. So in memory mapped IO, you can use all the instructions like move, or so for move in 8085 we used like MVI, LXI instructions, not the move instruction. Yeah, we have A, M also. Yeah, so all the instructions, data transfer instructions, can be used in memory mapped IO. But in IO mapped IO, you can only use instructions like in and out instructions. So that is the difference between IO mapped IO and memory mapped IO. Here you can have 16-bit address. Here you can have 16-bit address in memory mapped IO, and in IO mapped IO you can have only 8-bit address. Now we'll see a bit more into the comparison part of IO mapped IO and the memory mapped IO. So yeah. So here I have jotted down some comparisons between memory and IO mapped IO. So IO mapped IO is simple and cheap. Why? Because we are using 8-bit address. 8-bit address means the instruction becomes smaller. The 8-bit decoding circuit becomes smaller. So when you have an 8-bit address, you just have to decode these 8 bits. So the decoding circuit also becomes very cheap as compared to your 16-bit address, which you use for memory mapped IO. So the IO mapped IO has a dedicated 8-bit address, so which means that it is very simple, it's not complex, and it's very cheap. Whereas your memory mapped IO is complex because it has a 16-bit address, and you need 16-bit decoding circuit for decoding the input-output devices of your memory mapped IO. So there is a major difference between IO mapped IO and memory mapped IO. Another major difference is that you can connect up to 256 different devices in IO mapped IO. So generally, we don't require so many number of devices. Let's say you have a PC. How many devices do you use? You hardly use 4 to 5 devices. You have a monitor, printer, your mouse, keyboard, and that's it. Yeah, and you can have some bidirectional devices for like your pen drives, a few USB ports, and then your VGA port, or yeah, so maximum up to 10 devices or 10 ports. That's the maximum that you use in your uh, personal computers. But if you go to an industry where you want to connect a large number of devices, then the you might require more than 256 addresses. That is where this memory mapped IO comes into the picture, where you can connect up to 65,536 devices. So in an industry, you have probably a lot of devices that you want to connect to your processor. Yeah, so at that point, IO devices might exceed these numbers like 256. So there you might require a memory mapped IO, and that is where we have to use a lot more of addresses, where you will be mapping your memory addresses to the IO. So here you have dedicated 8-bit addresses which you mapped directly to IO mapped IO, and here the all the memory locations can also be mapped to IO depending upon the necessity. So also then here in IO mapped IO we are very much restricted with in and out instructions. We can't use any other instructions, but here we can use all kinds of data transfer instructions. uh, and you can also you can use any data transfer instructions. Also, you can transfer data with only a register in IO mapped IO, and but in memory mapped IO, you can transfer to any general purpose registers using the normal instructions that you use. Also, you can directly add or subtract. You can do arithmetic operations with your registers using instructions like ADI, or where you give immediate data from a memory location. Sorry, ADI is for immediate data. If you are accessing a memory location, then uh, those instructions where you are going to add the accumulator with the memory location, those instructions can also be directly given, and you can directly add data that is coming from an IO device. So that option is not there in IO mapped IO. In IO mapped IO, you'll have to take the data into the A register and then add it with another register or so. So these are the major differences. Also, there's a this IO mapped IO has 8-bit address. Here you have a 16-bit address. So that's all with IO mapped IO and memory mapped IO. Thank you for listening. Have a nice